Section 13.2 is about angles and angle measures. If you start with a coordinate plane, you can generate angles by rotating two rays around a fixed point in the origin. So if you look here in this coordinate plane, you can see that if I take a ray on the initial side where it starts and I rotate it, I get an angle. You can kind of see it better if I take this protractor and put it in place on the coordinate plane. You start down here on the x-axis, and that's called the initial side, and as you slide the ray, you create an angle. So you see how if I slide the ray all over to this blue one, it's about a 140-degree angle, 139, and you keep going and that value changes. So if I slide it to here, it's about a 50-degree angle. That's created by looking at the initial side where you start and the terminal side where you end up, which is what you see in the blue here. And you can actually go completely around the coordinate plane. You can get 90-degree angles by going straight up, 180 by making a horizontal line. You can get all the way down here to 270, and then eventually you can make an entire circle and get 360 degrees if you slide the terminal side around the entire axis. Now this is called putting an angle in the standard position. It's the position so the vertex is at the origin and its initial side, right here, is along the x-axis. Here we'll examine that the measure of an angle is determined by the amount and the direction of its rotation. So here's an example of an angle that has a positive measure because it goes counterclockwise. If you travel counterclockwise around the origin, those are the angles that are positive. And because it goes past the 180-degree mark, we know it's between 180 and 270. That's what this is. And this is 180. So this one is about 225 degrees. Angles that go clockwise are measured with a negative number. These are negative angle measures. So you start with the initial sign of the x-axis and you spin it clockwise. So this one has negative 210 degrees. And then the last one, there's a couple of angles here. One of them is 360, and the last one has a terminal side that once it started went around one complete revolution. So it went completely around to 360 and then kept going. So you're going to add the 135 that it went additionally to the 360 and you get a complete rotation plus more of 495 degrees. Here we're going to draw some angles in standard position. So for this one, 240 degrees, well, we're going to start in the initial side on the x-axis, and we know that this is 180 and this is 270. So 240 is going to be about a 60-degree increase, not about, it's going to be exactly 60 degrees past 180. So it's going to look like this. And so I start here, and I end up on the blue, the terminal side. I also want to point out that this angle, this small one from 180 down to here, is 60 degrees. But when you do the entire revolution from the x-axis, the initial side to the terminal side, you get 240 degrees. Over here we're asked to do a negative 30 degree. Well, that's going to be a fairly small one over here. Since we're going negative, we're going counterclockwise. So that would be negative 30 degrees. And in this one, 450, we're going to be 360 to get around here. And then we're going to be an additional 90 that gets us right here on the y-axis. And I'll show you how that works. Because you're going to go around 360, and then an additional 90 gets you to that spot. And since it's positive, we went counterclockwise, so that's what a 450-degree angle looks like. Here we're going to introduce the concept of a unit circle. A unit circle is a circle with a radius 1, so you notice this is 1 in every direction for the radius. Its center is at the origin. And there's a lot of information that you can find from a unit circle. As we continue through the chapter, we'll explore this a little bit more. But this is just an introduction to what the unit circle is. We also want to introduce the idea of a radian. Radian is a different way of measuring angles, not in degrees. And it starts by having an angle that's in standard position, but the rays intercept the arc of length 1 unit. So if you go up here and you see the arc that has a length of 1 unit, and you just spin this ray around it, you create a radian measure of 2 pi. It turns out that 360 is the degree measure all the way around, but 2 pi is the radian measure all the way around. Well, that would mean that 1 pi is halfway around, and half of pi is the same as a 90-degree angle, and 3 pi over 2 is the same as a 270-degree angle. Now, we will explore this a little bit more as we continue through the chapter. Now, there are times when you want to convert from radians to degrees and back and forth, and here's how to do that. If you want to rewrite a radian measure in degree, you multiply by 180 over pi. And if you want to write the degree measure into radians, you multiply by pi over 180. So here I have degrees, so I'm going to multiply this by pi over 180. And 60 cancels with 180 to leave a 3. So 60 degrees is the same as pi over 3. This is the radian measurement of 60 degrees. Over here, negative 7 pi over 4. To convert that to degrees, you multiply by 180 over pi. The pi's then will cancel, so now you don't have to deal with the pi's anymore, so no more radians. 4 goes in 180 45 times, and then 45 times 7, it's a negative 315, and this measurement is degrees. So negative 7 pi over 4 is the same as negative 315 degrees. So here you see the beginnings of this large circle called the unit circle, which gives us a ton of information. We've taken all the angle measures and converted them into radians, so you can kind of see what the most common angles are, both in degree and radians. You can see that a 90-degree angle is the same as pi over 2. You can see that a 60-degree angle is the same as pi over 3, and a 150-degree angle is 5 pi over 6. So this unit circle becomes an invaluable tool as we continue with trigonometry. Here we want to find both the degree and the radian measures of the angle that's created when we go from 1 p.m. to 3 p.m. So that means we're going to start here at 1 p.m. and we're going to end here at 3 p.m. So this is the angle that we're looking for right there. Well, since the clock is split up into 12 portions and we want to go from 1 to 3, that's really 2 portions. So that's 2/12 or 1/6 is the amount that we're moving on our clock. Well, 1/6 of 360 is a 60-degree angle. But if you notice, it goes clockwise. And because it goes clockwise, that's actually a negative angle. And so our answer here in degrees is negative 60. Now let's convert that to radians. If we take negative 60 and multiply it by pi over 180, 60 will cancel with the 180, leaving a 3. So we're going to get negative pi over 3 is the measure in radians. Our last slide, we'll talk about coterminal angles. These are angles that have the same terminal side. Here's an example. You have a 405-degree angle that ends up with this terminal side, and that shares its terminal side with a 45-degree angle. So they both have the same terminal side, therefore they are coterminal. So in these examples, we want to find one angle that has a positive measure and one angle with a negative measure that's coterminal. So let me put an axis around here. If I do 240, that's going to be somewhere down here. Well, one way to make an angle coterminal is just to add 360 to it, because that means you're just going to go around the circle one full time and then go 240. So that would be a 600-degree angle. So I would say 600 is a good positive angle that is coterminal to 240. The other way would be to figure out how far around going clockwise I am. And that would be another good angle that would be coterminal. In that case, I'm going to take the 360 and I'm going to subtract the 240. So that's going to be a 120-degree angle, but we're going to the left, so that's going to be a negative 120 degrees. We're going clockwise, so it's a negative angle. So 600 and negative 120 are both angles that are coterminal to 240. Over here, this one's in radians, so if I want an angle that's coterminal to that, I'm going to add an additional 2 pi. So if I want an angle that's coterminal to that, I'm going to add a 2 pi because 2 pi is one complete revolution around the axis. So if I add 2 pi, I'll find a coterminal angle. I'm going to make this common denominators by doing 4 over 4. So that's 9 pi plus 8 pi. So 17 pi over 4. Now to find the negative one, you have to realize that this 9 over 4 goes into 9 twice with some remainders. So this is actually bigger than 2 pi. So this is already one complete revolution around the circle. So I'm going to take the 9 pi over 4 and I'm going to subtract 2 pi. And we know that that's going to be 8 pi over 4. So 9 pi minus 8 pi is 1 pi over 4. So this is really the same as a pi over 4. But the problem with that is it's not negative. So I'm going to take 2 pi and subtract pi over 4. Again, that's 8 pi over 4 if I get a common denominator. And 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. But that's negative because we went in the opposite direction. So here's a coterminal angle that's negative, and here's one that's positive.